Hello everyone, hope you guys are doing well. So in this video, we're going to be solving some complex questions of how to differentiate composite functions. And this is from the same exercise 12.2 and question number 2. I'm going to do the highlighted parts as always. Okay, so we have a question here, which is part C of question number 2. It's 5 over 2 minus 3x. Okay, now as always, the first thing you want to do is you want to make sure that the question is differentiation ready. Okay, so what you want to do is you want to make sure, let's switch to a different color. You want to make sure that you have the denominator rewritten and written in the numerator with the power, of course, being minus 1. Okay. Next thing you want to do is you want to differentiate it. Okay. And now you can pretty easily differentiate it. All you got to do is multiply the power by the number that you have outside the bracket, which is 5. So that becomes minus 5. And then you have 2 minus, whoops, sorry, not 2x. 2 minus 3x, you reduce the power by 1, so it becomes minus 2. And then you multiply it by the differential of the expression that you have inside the bracket, which is 2 minus 3x, the differential of which is going to be minus 3. Okay, now minus 5 and minus 3 can be further multiplied, so that becomes 15. And then you have 2 minus 3x, the whole thing squared. Now if you look at the answer, sorry, the whole thing to the power minus 2. Now if you look at the answer at the back, you'll notice that this is not how they've written it. And as you know, it's always not always a good idea, but it's preferable that you write. It's a personal preference, okay? That I would prefer to leave my answer with a positive index, okay? It just looks nice, okay? Call this an OCD if you want, but that's how it is, okay? Okay, now we have some slightly more complex questions. Again, what's complex over here is that not that there's a different concept altogether. It's the same concept, but the powers are going to be in fractions. Okay. So again, the first thing you want to do is you want to make sure that it's differentiation ready. So 2x squared minus 3, instead of writing it inside the square root, I'm going to prefer to write it as power half. Okay. So now dy by dx equals to half into 2x squared minus 3, and then we take 1 away from the power, so it becomes half minus 1, which is minus half. Again, always a good idea to use your calculator if you're not too confident about your mental math, which is perfectly all right, nothing to worry about. And then you multiply it by the differential of 2x squared minus 3, which is going to be 4x, and then you simplify. So 2 1s are, 2 2s are. So 2 into x leaves us with 2x. And then if you want, you can shift 2x squared minus 3 to the power minus half in the denominator. When you do that, the power becomes positive, and that means we can write it nicely as 2x squared minus 3 inside the square root, which is the correct answer. Yep, that is it. That is the correct answer. Okay, same thing applies to part F. 4 into 2x minus 1 to the power half. Okay, now I'm going to differentiate it. So dy by dx becomes 4 into half. Okay, you can do it step by step if you want, or you can just straight away write it as 2 into 2x minus 1 to the power minus half, because that's what half minus 1 gives you, multiplied by the differential of 2x minus 1, which is going to be 2. Okay, now the good thing here is you can cross out this 2 with this 2. Okay, and then you now have dy by dx, which is equal to 4 over 2x minus 1 inside the square root, and that is the correct answer. Okay, so that's pretty much it for this video. Okay, so we're done, thankfully, with the concept of how to differentiate composite functions. In the next video, we're going to start off with product rules. So I'll see you guys then. Until then, take care. Bye-bye.